This team is formed by Sergio Sanabria, Emiliano Díaz, Ríos, and Brian Cedillo. Introduction and problem statement. In the industry, the process of manufacturing requires high levels of accuracy. Tecnología Industrial de Precisión S.A. de CB is a metal mechanic company which makes machining process for the automotive industry. One of the most requested products are steel bushings. This process is assembled in concrete trucks. To satisfy the customer, the drilling process must be within the specified tolerances. If not, the material will be rejected. In this process, the operator uses a drill of 18.5 millimeters. The diameter specified in the drawing is of 18.8, with a tolerance of plus minus 0.600 of a millimeter. The following research aims to analyze the data collected in steel matching process in order to increase quality in the drilling process done by the company and determine how well it is meeting the standards of the customers. The measurement is done with a vernier, which helps us to know the inside diameter of the bushings. In the manufacturing process, a strict control of the measurements must be kept. Since the specific mean is not obtained, the lot is rejected completely.
Okay, so the literature review and the method. Basically, we began this project measuring 30 steel bushings with the help of a flexometer in the facilities of Tecnología Industrial de Precisión S.A.C.B., following all safety guidelines. After having our data, in order to determine whether the diameter of the steel bushings, we used the following: the hypothesis test for mean, the Kolmogorov-Smirnov test, and the descriptive statistics. The first of these, which is the hypothesis test for mean, we will use it to determine if the mean of the sample is the same as the population's mean. This will tell us if the mean of the sample is significantly bigger than the mean of the population, or if it's similar. This we can use it because our sampling is done randomly, our data does not present any outliers, and it appears to have consistent values. Also, our total amount of samples is between 16 and 40. Here, we will be using the mean of the population, mean of the sample, and the standard error in order to standardize the data. We note that the null hypothesis is rejected if the p-value is less than the significance level, in this case 0.05, as we will use a 0.95 confidence interval. In this case, our null hypothesis would be mu equals 18.8, and our alternative hypothesis is mu bigger than 18.8. For the Kolmogorov-Smirnov test, it will help us to determine whether the sample follows a certain distribution or not. In this case, we will use it to determine if the data is normally distributed. Here, the null hypothesis is rejected if the statistical v is bigger than the critical value. With the goodness of fit test, we will be able to determine whether the observations could reasonably have come from the normal distribution. Lastly, for the descriptive statistics, we will use them also to confirm if the data follows a normal tendency. If the skewness and the kurtosis are between -2 and +2, it will mean that our data follows a normal distribution. Also, if the mean and median are similar and their difference is low, then it will confirm us that the data follows a normal distribution. This method will summarize the characteristics of the data of our samples and present these results in a simple way. We know that descriptive statistics are conformed of measures of central tendency and measures of variability. In the central tendency, the mean is equal to the median in a normal distribution. So this is what we're hoping to observe. If the histogram developed by this method has the shape of a bell and is symmetric, we can conclude that our samples follow a normal distribution.
Okay, so first I used for my part was doing the running the test to see whether the sample comes from a normal distribution. And with the descriptive statistics, we can see that the kurtosis and the SUS is between -2 and 2 range. So it consists of a normal tendency. So this data come from a normal distribution. Next, please. Then I run the Kolmogorov-Smirnov test, and here the null hypothesis was where the data comes from is normally distributed, and the alternative hypothesis is that it doesn't follow a normal distribution. And to know if the null hypothesis is accepted is if the statistic d is less than the critical value. And we can see that actually the statistic test d is less than the critical value. And lastly, I did the hypothesis test for the media using the standard error and the population media. And since the p-value is greater than 0.05, we accept the null hypothesis. Next, please.
Well, the discussion part, here's the part where we explain the results. So the histogram we prepared shows the sample and there's asymmetry between the data. That indicates that there is a little variability and standard handling can be given to the data. So when you standardize the data, you will have a real order and you will be able to give your analysis about them. In addition, it can be said that the data follow a normal distribution. So that means that they have a similar mean and median, and they do not have atypical values. Also, the Kolmogorov-Smirnov, as my partner said, it's useful to decide if the sample follows a specific distribution. And in this case, it follows a normal distribution. In the statistics test, the p-value, we have a result of 0.3317, so the null hypothesis is accepted, and we can identify the sample identical to the population media. Next. In conclusion, we have a little variability in the results, and the company can be satisfied with the methodology they use. In contrast, we can carry out a larger sample in field experiments, so we can be able to determine with certainty how variable and how consistent are the results. And our objective was fulfilled because we want to observe if this data follow a normal distribution, which was true.